Today we're starting our second unit. To start with on the second unit, we're working with prime factorization and the greatest common factor. Greatest common factor is usually just abbreviated as GCF. So that's what the GCF there is. All right, so on 14 in your workbooks, it says a blank number is a number with no factors except one in itself. Anybody know what that would be?
Prime.
Prime, yeah, it's a prime number. And then prime factorization, what that is it's a composite number written as a product of its prime numbers. So just to show, for example, 8 is a composite number. Okay? It can be made by multiplying other numbers. Specifically, the prime numbers that can multiply to make 8 would be 2, 2, and 2. So that is the prime factorization of 8. 2 times 2 times 2. Okay? Would 2 times 4 work? No. 4 is not a prime number. They need to go down as low as possible. So for this, you see a lot of 2s, a lot of 3s, occasionally a 5, occasionally a 7. Usually you don't go too much higher. I guess you could possibly get an 11 or something like that, but usually it's a lot of 2s, a lot of 3s, a lot of 5s. All right, then to factor a number to its prime factor, we're going to use a factor tree. It kind of looks a little bit like, you would see like a family tree. Hopefully, as your family tree moves down, it branches out farther and farther. Hopefully. So the factor tree kind of ends up almost like a Christmas tree shape, like a little like triangle as it gets wider at the base. And there's different ways to do it. You see this example there in your books. They start with the same number. They start with 48. There's a couple different ways we could do 48. Tree 1 started with 2 times 24. Tree 2 started with 3 times 16. If I were doing it, if I have 48, what two numbers multiply to make 48? The first two I think of actually would be 6 and 8. And then we just kind of keep breaking it down. To make 6, that'd be 2 times 3, right? To make 8, that's 2 times 4. To make 4, 2 times 2. And then, the ones at the end, they have them circled. So same idea. I've got A3 and 4, 2 circled. Well, that's exactly what they have as well. Just kind of different order on how it broke down. That makes sense? Like I said, you're just kind of like dividing it down or breaking it into pieces. All right, so this is one of the examples at the bottom there on page 14. It's like right there in the middle, 18. So what two numbers can I multiply to make 18? 9 and 2? All right. So I got a 9 times 2. 2 can't go any farther. I got it circled. 9 is what? 3 times 3. And again, don't go any further. So for 18, I would have 3 times 3 times 2. The examples they gave you on page 14, they didn't change the order or anything. For the most part, for like a test or something, the answer choices are usually in order from greatest to least on there. So that's why I put the 3s first, okay? All right, go ahead and try 36. All right, who can tell me what they multiply out, like this part down here at the bottom? All right, so what he had was, he said 3 times 3 times 2 times 2. Okay? When y'all did it, what do y'all break it into first? 9 and 4, 3 and 12, 6 and 6. A lot of different ways, right? All right, so 9 and 4 was what I heard first, though, so we'll show that one, okay? 9 times 4. 9 is 3 times 3. 4, we get 2 times 2. And that gives us, even in order then, the way I wrote it, 3 times 3 times 2 times 2. Okay? Any questions on this? Not crazy difficult. You just have to think about what prime numbers are, okay? All right, on page 15 then. A common factor is a number that is a factor of 2 or more numbers. What's a factor, though? All right, so what we did with those factor trees and prime factorization was we broke them into factors, okay? So factors are basically the numbers that go into a number, okay? We were specifically using the prime numbers for this, for the greatest common factor, or the GCF. We're not necessarily going to use the prime numbers for that. We're going to find the biggest number that goes into each of them. You'll notice this is kind of like simplifying fractions, right? When you simplify fractions, that's what you're looking for, is the biggest number that goes into two numbers. And sometimes you have to do it by pieces, right? So we can solve by using upside down division, or the ladder method is another name for that. All right, so our upside down division ends up looking kind of like this. So this is what the book shows you with 24 and 36. So look, here's how this ends up working. We're going to start with two numbers. I've got 36. I've got 48. What's a number that goes into both of them? 12? Let's start with something other than 12. 12 is going to get us right away to the answer. So we'll start with 6. Yeah, that'll work. I just want to show more how this works, okay? So 36 divided by 6 is 48 divided by 6 is, all right, so see at this point, we can keep going. What's the number that goes into 6 and 8? 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Can't go any further, right? So what we use for our answer are the two numbers on the left. So it's 6 and 2, and they get multiplied together. So 6 times 2 is 12. So like they said from the start, 12 is our answer. If you can figure it out right away like that, obviously that makes this a little bit shorter. I just wanted to kind of break it into pieces. If you're ever not sure, both of these numbers are even. What goes into even numbers? 2. That's basically the definition of an even number. Numbers that are divisible by 2, right? So if both numbers are even, you can always use 2 if you can't think of anything else. If both numbers are odd, or even one of the numbers is odd, 3 is a good possibility. Like we said, the prime factorization, if you use 3. If it ends in a 0 or a 5, 5 probably goes into it. So those are always ones you can try. All right, try this one, 24 and 64. That's right there. That's the middle example there on page 15. And your answer for this should be a number. Like on the one before, we got 12. All right, anyone think they got it? All right, he said 8. So, I mean, obviously that gives away the answer on where we're going, but we'll start with it and just kind of break it down differently. I'm not going to start with 8 right away. Some of y'all probably realized right away 8 goes into both those. I'm going to start with 2. They're both even numbers. I know for sure 2 goes into them. 24 divided by 2 is 12. 64 divided by 2 is 32. If I'm still not sure at this point, they're still both even, aren't they? That means 2 goes into them. 12 divided by 2 is 6. 32 divided by 2 is 16. Again, still even. I can keep going with 2s. 6 divided by 2 is 3. 16 divided by 2 is 8. Nothing going into 3 and 8. 3 is prime. 3 does not go into 8, so there's nothing else I can factor out. So what I factored out were 2, 2, and 2. And we multiply them together. 2 times 2 times 2. 2 times 2 is 4, times 2 again. Gives us that 8 we were saying. Make sense? Any questions? All right, let's do one of those word problems there. All right, so this is where this really comes into play, something that you could use kind of in life. Warren has 60 carrot sticks and 42 celery sticks. He wants to package them in plastic bags so that each has an equal number of each. That's not saying there's the same amount of carrots and the same amount of celery in each bag, okay? That's saying each bag has the same amount of carrots, each bag has the same amount of celery. In the individual bag, you could have possibly more carrots than celery. That makes sense? It wants an equal number in each bag of each type. All right, so we need the greatest number of bags he can put together. Well, what we're doing is we're taking 60 and 42, and we're finding our greatest common factor. The way we know we're looking for the greatest common factor is it's asking what is the greatest, in this case number, greatest something. If it's asking you what's the greatest, you're probably doing greatest common factor. All right, so 60 and 42. What goes into both those? 6. All right, so I divide that by 6. 60 divided by 6 is 10. 42 divided by 6 is 7. Well, 7's prime. We can't go any further. That's our answer. All right, if you would have started with 2 because they're both even, that would work. You just would have one more step to go by the 3. Any questions on that one?